Good morning, folks. Welcome to the third day and final day of Ag Days. Thanks for braving the cold so early this morning. Just want to remind you just some housekeeping. If you don't mind turning your cell phones off, or at least put them to silent. And if you're here and need some crop CCA credits, there's a sign up at the back there. So we'll get right into it and keep things rolling along here this morning. I should introduce myself. I'm Jim Bambridge. I'm with Farm Credit Canada. Work out of the Brandon and the Clarny office here. So this morning we have with us Tammy Jones. She's a weed specialist with Manitoba Agriculture. Tammy originally hails from a small town or small farm near Napinka, and she's earned her Bachelor of Science in Crop Protection from the University of Manitoba, where she also taught weed identification in labs and studied multiple herbicide-resistant wild oats. She's returned to Manitoba after 8 years in Alberta, where she worked in the private industry, as well as the Alberta Pulse Growers Association. Prior to that, she'd worked in Manitoba Agriculture as a diversification specialist for the Manitoba Pulse Growers Association. So without further ado, I'll turn it right over to Tammy.
Thank you. Jim already warned me that he'd flash me when I start to go over time. He said his phone light, but I'm not sure, so we'll make this short. Okay, so the topic this morning is stack rotator layer, strategies for managing herbicide-resistant weeds. And I do have a tendency every once in a while to go off on a little rabbit trail, so if I miss a point that you really need me to talk to, make sure you ask a question at the end of the presentation. So just as a backdrop, let's talk about what resistance is versus what tolerance is. So tolerance is really the ability of a plant to survive after a herbicide treatment without any genetic selection or manipulation whatsoever. It's just naturally tolerant. And the weed that I have up here, and let's see if I can make the pointer go. I can. Okay, so that's lamb's quarters, and it has a very waxy leaf surface, so sometimes it'll tolerate a herbicide just because of that physical barrier. It's not actually resistant to that herbicide, it's just a tolerance thing. There are others that, like wild buckwheat, where glyphosate doesn't really move through the plant very well, and that's a tolerance situation as well. It's not actually resistance. Okay, resistance, on the other hand, is the inherited ability, so that it has to actually pass from one generation to the next. So the seed needs to be resistant as well. And it has to survive and reproduce following a dose that's normally lethal. So this can be done through just sequential selection. Eventually you get a resistant population, but it can also be done through a variety of lab techniques such as mutagenesis or that sort of thing. Okay, so this is a basic slide. I stole it from the government of Australia because I do not have good drawing skills, and this really shows you how resistance develops. You have a field, you have that 1 in a million weed that is resistant because of a genetic mutation, whatever the case may be. You spray it. No spray ever kills all the weeds, let's be real. It kills most of the weeds, but not all of the weeds. So you're left with a couple that aren't resistant and one that is resistant. So now all of a sudden a third of your population is resistant just by one resistant plant still surviving. 3 years later, before you spray, you end up with all those red plants that are the bad resistant plants, and some nice green weeds that are not bad weeds, but you spray it again, and after spraying, you've selected for the majority of the population to be resistant. And as that seed sets, it spreads, and you end up with major patches, and then fields, and then yeah, it takes over the world, I suppose, if we want to go there. And so this is just some ideas of how resistance can spread once you've got it in the field. So again, that same type of diagram as sequential selection, but then it could be wildlife. This is the best weed seed spreader out there. And funny story, not only can it spread seeds within a field and from field to field, it can spread them from country to country. Because I know a guy that has water hemp over in eastern Manitoba, and it's because he bought a combine in the States and brought it up, and it has a weed seed in it that brought him water hemp. So it's the gift that keeps on giving kind of thing. Also, something like this is a tumbleweed sort of situation. It's kosher rolling through a field and spreading that way. So lots of ways for it to spread once you have that 1 in a million plant. So let's talk about some of the strategies to mitigate that risk of spread more than anything, because we're never going to shut the door now that it's open as far as resistance being out there. One of the early ideas was herbicide rotation. And so what they looked at, this is Hugh Becky, who's now retired and down in Australia, doing some more herbicide resistant stuff. He developed this pyramid that looks at the risk of herbicide resistance development based on the different groups of herbicides. So group 1s are mainly your wild oat killers, your selective ones like that. Group 2s are your broadleafs. A lot of broadleaf weed control is in your group 2s. They're very strong at killing weeds when the weeds aren't resistant, but that strong selection pressure also means that they are a high risk for developing resistance. And that doesn't mean that it's going to be immediate, but you know, after 2, 3, maybe 10 applications of a herbicide, you will have resistance to that herbicide within that population, just because of the genetic diversity of the population and then that selection. At the bottom end, the group 4s, the group 9s. So group 4s is like your 2,4-Ds and your MCPAs. Group 9s, everyone's favorite glyphosate, right? Group 10, glufosinate or Liberty. Those have a lower risk, but low doesn't mean no risk. It just means that it probably takes more time within an agricultural setting before you'll see resistance develop. So let's take a look at cases of resistance. How have we been doing over the years? So you can see that it's a pretty sharp curve, and we're at 496 different species that have resistance to some herbicide out there. And in some cases, it's a species that has resistance to 11 different modes of action within one plant. So we've done really good at developing some herbicide-resistant plants out there. Let's look at some of those ones that were back on that herbicide pyramid and see how it worked as far as what the risk of developing resistance was. So this is the group 2s, okay, those broadleaf weed killers. And the first product was introduced, registered in about 1980, and right about 1980, we see that there was resistance because it's just naturally in that population. Group 4s, okay, they were introduced back in the early 40s, mid 40s really, and it took a while before we ended up seeing resistance to that particular chemistry, and then it took quite a long time before we got to the next one at about 1980. So much slower development of resistance. And the group 9s, all right, looks like a steep curve again, but you can see that it wasn't until 1996 that we had our first case of resistance. Well, the product wasn't registered. It was back like 1980 again. So we used it for a really long time on a lot of acres before we got resistance. So it speaks to how those different groups, there is different speeds at which they develop resistance. So what does that look like in Manitoba as far as herbicide resistance? So in 88, we had green foxtail and kochia with resistance. And it kept building. We found wild mustard. We found wild oats. And by we, I really do mean that we found it. So there's me back in the day at the University of Manitoba confirming that group 1, 2, and 25 wild oat resistance. So it was first discovered back in 94, but we didn't really study it until 96, 98. Green foxtail, red root pigweed with group 2 resistance. We weren't getting a lot other than wild oats where we're getting multiple herbicide resistance. And then you can see that, you know, in 2014, 2015, wow, wild oats with 1, 2, 8, 14, and 15. Okay, we're getting serious about that as far as lots of groups of resistance. And then this is also the time when kochia, group 9 and group 2 resistance was first confirmed. You see that next star there with 2016. We did a harvest weed survey and just by accident found that there was yellow foxtail that was herbicide resistant to group 1 and 2s, barnyard grass that was group 2 resistant, and shepherd's purse that was group 2 resistant as well. And as we're going along, we've been talking about herbicide resistance and we've been telling people to rotate herbicides, and yet we're finding that with wild oats and green foxtail, 32% of the fields are herbicide resistant, and then 48%, and then 68%. So that rotation is obviously not doing the job that we need it to do. Why is that? So the theory behind herbicide rotation is that it was going to delay the onset, but it was never going to like stop it. It's just going to lengthen the time out. And it was going to delay the onset to any one mode of action. And that by rotating the herbicides, we'd see less risk of widespread resistance because in theory, those weeds that are herbicide resistant are less fit. Okay, so they have this fitness cost associated with the resistance. Either they're less competitive, they produce less seed, whatever. And why do we think that? Well, if herbicide resistance didn't have a fitness cost, wouldn't all the weeds be herbicide resistant right from the beginning? Why did we have to select for them? So the theory was that there was a fitness cost. That's me. That's no. There's not. There are some cases, fluroxypyr resistance in kochia, we're finding that there is a fitness cost with that. But those wild oats, those green foxtails that we weren't necessarily selecting for really because we were trying to rotate herbicides, we were still developing more herbicide resistance. So the fitness cost theory didn't work. So herbicide rotations may delay. It's a baby step towards managing herbicide resistance, but it isn't going to be the solution. So then, stack, rotate, that whole Jenga analogy that I had up there. What's herbicide stacking? Hear it out there every once in a while and you're worried what it means. So stacking is the repeated application, typically of a residual herbicide that is the same mode of action. Group 2s are the ones that are pointed out a lot, right? The Odysseys, the imatazolinones, those type of things, that they linger a little bit in the soil and they can cause carryover issues into the next crop. And so there was a lot of research that was done on that about how that repeated application concentrated in the soil, accumulated a residue, what the impact on the environment was, and all that sort of thing, and the impact on the next crop. Okay, I'm one-dimensional. I only care about weeds. Sure, we found that there's short-term accumulation in certain soil types under drought conditions, typically. But from a weed perspective, what does that herbicide stacking mean? Continuous selection pressure, because the herbicide's always there. So then all you're doing is selecting for a resistant weed. So once again, there's me. Herbicide stacking is also bad for managing herbicide resistance. So then we go to herbicide layering. Well, how is layering different from stacking? Okay, layering is using multiple active ingredients from different groups instead of the same group, and to control the same weed in the same field in the same year. The only thing that I find really challenging is to get it all in the same tank, right? So let's maybe do it in more than one step. So that's part of the layering process as well. It can provide improved weed control even when you don't have resistance, so a pre-seed and then an in-crop to help with crop competition, and it can be used to reduce multiple resistance in one weed or address a bunch of different weed problems in a field. So for me, there's a thumbs up. I couldn't find a little thumbs up girl. I could only find the face palm girl. But herbicide layering is a tool that we need to use more. And so one of the other things that people ask about is herbicide tolerant crops. Are they causing issues or are they helping us out? They're another tool. They can add some new chemistry into a crop that they didn't necessarily have the opportunity to use it there. But using it and abusing it, just like everything else, will cause us to get to a spot where we have herbicide resistance. So this is herbicide layering in canola with a herbicide tolerant crop, so glyphosate, and we're looking at cleaver control, which has been an issue. And so in an unsprayed, this is done at the University of Saskatchewan. Chris Willenberg did it, and they found that unsprayed, you've got a lot of cleaver production. So this is biomass. Here are two different treatments. Unsprayed, glyphosate alone doesn't linger, kills it once. It does an effective job of killing cleavers. Quinclorac, so that's a group 4. It'll do a not bad job on cleaver control. Clomazone, that's a group 13. Pre-seed. Pre-seed alone, it doesn't do a great job on reducing biomass, but it does reduce it from the unsprayed. And then you get the layering, okay? So a pre-seed and then an in-crop, wow, you get good weed control. And in all of these situations, when you're doing more than one active ingredient, maybe more than one timing, you're getting better control. And so as a yield response, you can also see that when you do that layering, you end up with higher yields. It might cost a little bit more, but not only are you getting better weed control, but you're getting that higher yield as a response. They also showed the same thing in Liberty. So again, herbicide-tolerant crops are an opportunity to put in some new tools, and then the layering adds to that. And there's the yield response. Layering helps. Okay, so this is Bob Hartzler out of Iowa State. He shows this, he showed this on Twitter the other day, and so I stole it because I think it's a good diagram of how layering works. So we have a traditional soybean program, which I wouldn't say is necessarily irrelevant for us. I think it works pretty good for us. Maybe the timeline's a little bit off, but nonetheless, use your imagination as to that. So we have a tillage up front. They put in a residual herbicide. They do a post-emergent herbicide of some sort. And then before canopy closure, because you've got wider row spacing typically with soybeans, there's this vulnerable period. So what they're doing in Iowa is looking at layering and prolonging that pre-seed activity until the canopy fills. So they're putting in a residual and then another residual to keep those weeds at bay. And the reason that they're doing this is for some flushing weeds like bad weeds, water hemp, Palmer amaranth, all the ones that give us the heebie-jeebies. We have similar ones, maybe just not as grandiose, like glyphosate-resistant kochia that flushes. You can use a similar kind of concept for that. Okay, so my only concern in here is multiple residuals. They have a longer crop season, they have better time to break down, so I worry about that. I do a pre-seed residual, but then maybe one or two in-crops that are maybe non-residual, so that you maximize your recropping opportunities. Here's another look at it. This is water hemp out of the University of Minnesota, and again, look at a pre-seed, and then they put in a layered residual to get control till August. Again, I worry about that recropping restriction, but the layering idea does a really good job at reducing weed problems. So weed pressure without the residual, 76% control. With that layered, 94%. Which field are you going to want? You're going to want the one that's got less weeds in it. Because from a herbicide resistance management perspective, the less weeds you return to the field, the less weeds you have to battle the next year. So again, I already mentioned this. You got recropping restrictions from that residual or extended control herbicide, so that's a really important consideration. You need to take into consideration your soil moisture, your soil texture, all those kinds of things, and your use rates as well as the time of application. So if you're doing a rescue treatment really late in the season, like July, you're going in with something that has some residual to it, you need to anticipate that you're going to have more recropping restrictions with it than if you're applying something in June, right? Because it just has less time and probably less soil moisture to break down with. So those are all things that are going to need to be taken into consideration. Okay. Let's see if we want to go to the next slide. Oh, we do. Okay, so managing for success, right? Because at the end of the day, that's what we're looking for, success. So I want people to scout their fields 5 times for weed control, at a bare minimum. How popular am I? Okay, so before you even go and seed it, to make sure you know what's there, and probably do a pre-seed burn, because rarely do I get a guy that says, oof, wish I hadn't done that pre-seed. Boy, I didn't do anything with that. It's almost always a benefit. Scout before you seed, before you do that first in-crop, to make sure that you've got the weeds and that you're using the right modes of action for those weeds. After you spray it, to make sure that it actually worked. And if it didn't work, spray or use some other control methods to make sure that you control those weeds. That could be tillage, and we'll get into those in a second. And then I want you to spray it, or I want you to scout it again right before you harvest to make sure that you don't need to do something pre-harvest. I want you to scout it after you've harvested to see if you need to do something then, or at least know what weeds you're going to have to deal with next year. So 5 times for weeds, and I don't care about insects and diseases and all that stuff. You can figure that out on your own. 5 times at least for weeds. Okay, apply effective herbicides effectively. So we get, and I'll show you a chart a little bit later that talks about multiple modes of effective action, but that is a key for us as well, right? That's how we're doing herbicide, or why we're doing herbicide layering. Multiple modes of effective action. What does that mean? So multiple modes, pretty simple, but the effective action. Throwing 2,4-D or MCPA into a tank just as a top-up doesn't necessarily mean that you're adding another mode of action that's effective. It's probably just a feel-good for you in certain situations. You need to have the right rate. You need to be applying it at the right stage. For instance, bromoxynil and kochia, it's the 1 to 4 leaf stage. Does anyone think about that when they're spraying their kochia with bromoxynil? Like, no one sprays at that stage because no one can see the kochia at that stage. It's teeny tiny stuff. So you have to have the right stage, the right rate. It needs to be in the right weather. We also need to talk about water volume, our droplet size, all that jazz to make sure that we're getting it into the plant. And then apply that different modes of action within the season. So this is where layering is one of the tools, but it's not the end-all be-all of how you're going to manage herbicide resistance. And again, sequential applications is probably the way to go, because if you try and throw everything into one tank, you're probably making glue rather than an effective tank mix. And rotate your chemistries through the crop rotation. Crop rotation is important too. And then this is another one that makes me incredibly popular with most audiences, zero tolerance. It's a pretty realistic level, don't you think? Zero tolerance. I do not want any weed escapes. Okay, I know that's not reasonable, but that's where I'm setting the bar so that when you underperform a little, we have something to work with. But control your escapes however you need to, whether that's mowing, whether that's tillage, whether it's hand weeding. Especially important on field perimeters, drown out spots, and non-crop areas where we see a lot of weeds proliferate, right? So that's really important. What are some other things that we need to do? Herbicides are a tool, but they're not everything. They're not the end-all be-all. We need to start looking at other things, because herbicide resistance was caused by herbicides, not by tillage, or not by increasing your seeding rate, or not by narrowing your row spacing, all of those types of things. Okay, cultural control methods, crop rotation, like I just mentioned, your crop type. So some crops are more competitive than others. When you're looking at that, rye is really competitive. Okay, I don't really love rye because it doesn't fit into my crop rotation. Okay, fine, then go oats, barley, wheat. You're going to put those broadleafs like flax, lentils, or peas, or soybeans in there as well, but know that they're not as competitive. So maybe that's the year where you need that pre-seed residual, and then are very vigilant in crop as well. Use certified seed. Better germ, better vigor usually, and also you're not putting somebody else's weed seeds into your field theoretically, right? There's usually less weed seeds there. Seeding date, change it up. Seeding rate. More is better in my world. Might be costing a little bit more, but if you can close in that canopy quicker. The other option, cross seeding. Some people really think that that is quite a nice idea. I don't know how many of you want to go across the field twice, but seed east-west and then north-south so that you get a quicker canopy closure. Row width, narrower for more rapid canopy closure. And fertilization. I don't believe in weed and feed. No broadcasting that fertilizer to feed your weeds. Try to side band it, seed place it. I know there are limitations to that too, but those are going to be the ones that are going to help your crop more than your weeds. And John Hurd, who's in the audience, ready to heckle me at a moment's notice, has this great picture that he wants to share with me someday about how you can see when you place fertilizer for weeds, they'll use it rather than the crop. So someday John will give me that picture, and then my presentation will be even better. Okay, other things that we need to start thinking about. Cultivation. I know that's really a challenging concept, especially, I'm from Napinka, the Waskata. Zero till is sort of our thing. But sometimes judicious tillage is the way to go. We don't have a lot of iron resistance yet. We have herbicide resistance, but not a lot of iron resistance yet. So it needs to be used. They're looking at some great ideas, like inter-row tillage. And I don't mean inter-row on 30-inch row spacings. I mean inter-row tillage on your 7.5-inch row spacings, looking with cameras to make sure that you're only in between the rows. So it could happen in more crops. It's another way to try and get rid of some weeds. Mowing, so there's a couple of different options here. One is just to mow a patch out. This comb cut, it's looking at cutting off the seed heads over top of the crop. It's a different idea. Harvest weed seed management. This is another one that I think might be cool for some, and they use it a lot in Australia because they have a lot of resistance issues there. But it just goes on the back of the combine now. The Harrington seed destructor used to be something that you pulled behind, and then you get into a hill and you jackknifed, and it was a crazy, horrible thing to do. Now they just attach it to the back of the combine, and it crushes the weed seeds as they're going out. Okay, here's the argument. All the weed seeds shatter before they go through the combine. Really? Then how do you have dockage? Okay, so you're not going to get 100% control with this, but you're going to reduce it. And you need a lot of reducing, because with herbicide-resistant weeds, you're never going to get 100% control with anything. So there's that integrated one on the back of the combine, and then there's a seed terminator as well that works very similarly. Okay. Weed of the year in 2018 for me was kochia. Everyone called me about it. I told you bromoxynil, you need to spray 1 to 4 leaf in order to get kochia control. Can you count how many leaves are on that kochia? More than 4. Look how small it is. It's really hard to control kochia. The other fun fact about kochia is that it'll germinate after 50 growing degree days accumulation. So that's really early. And then it'll just keep germinating through the year. So that's fabulous about it. And then it rolls around and spreads to everyone's fields. Okay? It can do up to 30,000 seeds per plant. There's a lot of resistance in it. So I think that's where we're going with this is we don't have water hemp or Palmer amaranth yet. So let's learn with kochia that's seemingly easier to control. We haven't been doing a great job of that. So found a few fields this year. This is soybeans. This is a dead kochia. This is a live kochia right beside it. This varying response, just like this varying response, and this, there we go. Dead kochia, live kochia right beside it. Okay, so those are telltale signs that you probably have a mixed population, and you've got some resistant ones, and you've got some susceptible ones. So then we send it to a lab. You can do it with a leaf tissue analysis. Quick PCR, 7 days, they can give you a result and tell you whether you have resistance or not. So you know whether you should try spraying it again with an appropriate rate for the stage that it's at, or whether you should beat it with the jug, or whether you should just give up and go pull them by hand or something like that. And back in 2016, so 2013 was when we had the first glyphosate-resistant kochia. In 2016, when we generated the map, we had 5 municipalities, the yellow ones, that had glyphosate-resistant kochia. This year, here's this year's map, there's 12 municipalities that are there. The only reason that there isn't more yellow on there is because of the data set that I used. So this is only using our harvest weed survey from 2016, and then anything that was submitted to the lab for this PCR analysis in Winnipeg. But I also know that this should be yellow, and I know that this should be yellow, and I know that some in there should be yellow as well. And if you're in this strip here, and you think there's some magic dome that's keeping you away from glyphosate-resistant kochia, oh, you're delusional. I don't know what other word to use there. But so the data set is the only thing that's limiting this from being more yellow. So with what we're doing for management techniques, we are not doing a great job of managing glyphosate-resistant kochia. What if we get some of those other weeds that are even more dangerous? Okay? So what are some things that we should be doing with glyphosate-resistant kochia? Okay, so this, you saw this earlier. This is me going through a field, testing it, and dropping a pin every time I find a kochia that I think is suspicious. I would go back and hand pull those, because that's going to be the quickest, easiest way to get rid of that particular patch, because it's really a line in the field. Unfortunately, that gentleman threw it through the combine and spread it out. So we should see next year a very interesting looking field. This is all kochia seed right around where that kochia breaks off. So yes, we can spread kochia, it tumbles, but about 90% of your seed is right where it grew. And if you've got 30,000 seeds per plant, then you've got a problem in that patch. So try to make sure that you, Jim just flashed me and now I'm blind. Make sure that you manage those patches. Mow them, silage them, bale them, spot tillage. Okay, so baling it might not be great because you don't have any livestock to feed it to, but baling it and composting it is going to be more effective than leaving it out there to spread and have to try and control it next year. Minimize seed set to reduce the long-term impact of resistance. Okay, we tried a post-harvest study. So when you cut off kochia, it just regrows and sets some more seed and it doesn't like you. And in Montana, they did a study and estimated about 4,100 seeds per plant after it was cut off by the combine in late July to, mid-August. So that's not a solution, just cutting it off with a combine. So we could find in a field trial that I did that you can definitely kill kochia post-harvest, but you don't eliminate seed set. So it's an option if you really want to try, but it's going to mean that you're still going to have some viable seed that you're going to have to manage next year. And in a patch like this, viable seed, there's a lot of it in there, right? So we do have some dead patches, but I'm not suggesting that post-harvest is the way to manage it. It's just another option. Okay, so really quickly, where are we at for herbicide-resistant kochia? In Alberta, they did a survey. 100% were resistant to the group 2 herbicides. 50% resistant to glyphosate, 8% resistant to dicamba, 10% were resistant to all 3. In 2018, we did 300 sites here. Those will get sampled those will get tested this spring, and we'll be able to find out what our population is looking like. I'm going to skip this, but all it's showing you is that we have multiple resistant dicamba, glyphosate, and group 2 resistant kochia in Alberta, and it's going to come our way. And again, multiple resistant kochia, not only to dicamba and glyphosate, but we're also talking fluroxypyr, which lots of people have in their tank mixes as an added kind of mode of action, but we're going to see resistance to it come up from our selection pressure as well because they've selected for it in the States. They also have some other so photosystem 2, which is a group 5 one. So we're not going to manage herbicide resistance with herbicides alone, and we need to go to some of those other successes. This is our control options for glyphosate, or for kochia in wheat, sorry. So this is straight out of the Guide to Crop Protection. I stole this out of there. And these are the different tank mixes. And what I did is I narrowed it down to the ones that weren't a single mode of action, because one mode of action isn't enough. That reduces the list a fair bit. And then I thought, okay, if we have resistance to some of those modes of action, then what are we left with that we know of in Manitoba? So I took out all the group 2s, because 100% of the samples in Alberta were resistant to group 2s, and we have a high level here as well. Okay, now our list in wheat is very, very small. And there isn't a lot of variety in which groups we're relying on for kochia control. So we need to use those judiciously. And that's why some of those herbicide-tolerant crops, like Enlist soybeans or Extend or some of those others, might help us as well by adding in. Okay, so these are the ones that we're getting scared of because they're coming closer, and I felt like I needed to mention them because if we can't manage glyphosate-resistant kochia, we are not going to be able to manage these well either. So water hemp, we have a few sightings in Manitoba. It's a noxious weed, so when we do see it, it's supposed to be reported to me, and then I'm supposed to monitor that site to make sure that we destroy everything, keep that under control, because it is going to be an agronomic concern. So C4, so it likes hot, about 500,000 seeds per plant. I saw on Twitter yesterday someone saying that it grows about an inch a day in good conditions, so staging becomes quite an issue. And if you think water hemp is scary, Palmer amaranth is like water hemp on steroids. Okay, and it will grow 2 to 3 inches per day. So that just proves my point. So staging again, and it'll produce up to 1 million seeds. So we need to be really smart on the glyphosate-resistant kochia, figure out our strategies, utilize an integrated weed management approach so that when these do come our way, and that's Palmer amaranth, that's the distribution map for it, that's kind of close. So we got to be careful. Okay, final slide. Not picking on anyone, but this was out on Twitter as well. And it's just a case of be sure you know where your information is coming from, okay? So you don't know me, well, some of you do, but not all of you do, so maybe don't trust the information from me. Don't trust the information on Twitter. This was out on Twitter. This is Palmer amaranth, supposedly. Those are the Palmer amaranth seeds, and it'll do 100,000 seeds per plant. Well, I just told you 1 million seeds. I will also tell you that that was a common ragweed plant that they had there, and this is actually Palmer amaranth. And that's actually what Palmer amaranth seeds look like. They're just red root pigweed seeds, basically. And then we adjust it to there. So this is the revised copy. I haven't sent it back to them yet, but I'm hoping that they take my editing for what it's worth. It's just saying when you're looking for resources and you're trying to get advice, make sure it's from someone you know and trust, not picking on anyone. And with that, if there's any questions.
Thanks, Tammy. I guess if someone can come up with a practical use for kochia, that might go a long ways too, eh? We got a few minutes. If anybody has any questions, just put your hand up and we'll try and get them answered.
Yes, sir.
So when, let's say you want to mow coach, when you have to mow it, when is the seed viable?
Okay, so the question that was asked is, if I'm going to use mowing as a way to control kochia, when do I need to mow it? Because when is the seed viable? That's a really good question. We don't know that one. What we do know is that we have to wait, for instance, until late July, early August, before we do any seed sampling, if we're sending it away for testing for herbicide resistance, because we don't typically have viable seed until then. So if you mow it mid-July, that type of scenario, you will reduce the seed set, but you will not eliminate the seed set because that short stuff will still produce seed because it knows now that you're mad at it and it's going to be vengeful and start madly producing seed to try and compensate for the fact that you cut it off at the top, right? I do like mowing better than tillage at that time because there's still green material growing in typically a saline spot, and so you're addressing a moisture problem at the same time as you're mitigating the risk of that seed set. So a couple of mowings, mid-July, late July is probably helpful, but it's only going to minimize your seed set, not eliminate seed set. Good, I've put them all to sleep. Excellent.
Okay, let's give Tammy a round of applause. Thank you.